All right. Let's look at 6.07 continuous random variables. Two goals today. Determine the probability of an event using a probability distribution histogram. That's another word for bar graph. For a continuous random variable, interpret probability distribution. So what is continuous? What are continuous random variables? Here's the definition. A variable x is a continuous random variable if it can take on any value in the possible range of the random variable. For example, if you roll a six-sided die, you can land on 1 through 6, but you can't land on 1.5 or 2.5 or something like that. It has to be 1, 2, 3, 4, 5, or 6. So you can't make x any value within that range. Okay? But an example of where a continuous random variable exists is if you're looking at waiting times in a doctor's office. You could wait for 5 minutes and 5 seconds, or 5 minutes flat, 6 minutes, 20 seconds, all different possibilities. So that means the variable can take on any value in the possible range. So that's what we're being told. We can use any value in the range, and you'll get a better idea of what this truly means on the next slide. And as we work through these more and more, please also know we will be doing a little throwback to geometry, finding areas, because, well, if you can find the area, you can find the probability with the type of graphs you'll see today. Here's an example, interesting looking graph. An incubator is being used to hatch chickens. The incubator temperatures X, we see them here, in degrees Fahrenheit are distributed according to this probability distribution. When all values of a random variable X are equally likely to occur, the resulting probability distribution is called a uniform probability distribution. Think about any type of uniform, police, firefighter, you name it, they all look the same, right? Well, uniform here, all probabilities are the same, resulting in that flat top. This is a uniform probability distribution. So if you look at those values in a table, all probabilities will be the same. And let's break down what's actually happening here, because we're not saying that it's going to perfectly evenly work out where quarter of the time the temperature will fall in this, I should highlight below, fall in this range, and then it'll fall in this range. No, remember, these are probabilities. These are approximations of what is likely to happen, okay? The horizontal x-axis ranges, as you can see, from 100 to 105 in increments of 1. The vertical p-axis ranges from 0 to 0.5 in increments of 0.1. And the bars have the same height as we've seen on the graph and in the table. For the incubator, all the values of x from 100 to 104 are equally likely to occur, right? That's why we see that flat top. And because any temperature between these values, like maybe 101.5 or 103.9 may occur, that means this is considered a continuous random variable. Basically, whenever we look in this incubator, we will find a temperature somewhere between 100 and 104, and it fluctuates, kind of like your AC in your home, right? If you have it set to auto, it will max out at a certain temperature and then drop, and then when it hits the lowest temperature, it will go up. So it's fluctuating throughout, and there's an equal probability of any given time you look, the temperature being in one of these four ranges. Well, a moment ago, I said you can use the area, and I'm going to prove it right now to find probabilities. For instance, suppose the temperature of the incubator is taken at 10 a.m. And we want to know the probability that the temperature is between 101 and 103. So we're really focused on this light purple rectangular region. Remember, the entire region is from 100 to 104. And to answer this question, basically, we are taking the area, or finding the area, I should say, of this light purple region. And here's how it would be asked. Find the probability that X is between 101 and 103, also including 101 and 103. Hopefully you remember the area formula for a rectangle, that is base times height, one of the most classic foundational formulas in geometry. And the base is 2. Why is it 2? I see decimals here and pretty big numbers there. How did we get 2? This is one of the most common mistakes, guys, so pay close attention. It's a distance. The base is the distance from the left to the right of that region of the graph. So from 101 to 103, that's only a distance of 2, right? And then the height, well, we can clearly see this goes up to 2.5. So height 2.5. We multiply those together, giving us 0.5 as a percent is 50%. So really what that means is if we look in the incubator at 10 a.m., there is a 50% chance that the temperature is between 101 and 103. And does that look accurate? It's always a good way to kind of just check your work. Does this light purple rectangular region look like 50% of the entire larger purple rectangle? It does. So we're good. We're feeling good about that. And now we're ready to look at triangle. This is considered non-uniform continuous distribution because the probability is changing. It's going up and up and up and up. Anytime you look, the probability is changing. So probabilities are different. This is not continuous distribution. And this is a situation where all values of a random variable x are not equally likely to occur, not at all. Let's just make sure we understand what we're looking at. Where is the probability the highest? Well, at the top, right? Right there. Right here. At 0.4. Highest probability. And what does that mean in real life? Well, we weren't given a specific example here, but it means at 4, whatever that value of 4 is, we have the highest chance of whatever it is happening. But what if we wanted to find the probability of a certain region of this? For example, the probability that x is between 1 and 4, including 1 and 4. Well, that's going to form a trapezoid. That light purple is a trapezoid. Could you tell me what a trapezoid is? Maybe the definition? If not, do you remember the formula? Well, if you don't, that's okay. I'm going to remind you right now. The trapezoid is a quadrilateral, meaning a shape with 4 sides, with one pair of parallel opposite sides. Where are the parallel opposite sides? Hopefully you notice they are right here. Let's get a nice red here instead. Right here and right there, parallel opposite sides. Okay? And here's our formula. Area equals half height times B1 plus B2. Those stand for base. But what is B1 and B2? Well, I'm telling you right here, these are the parallel sides. And it doesn't matter which is which. You can label this side as B1, this side as B2, or vice versa. And if you're thinking, wait a second, isn't that the height? Isn't the ground to the top h the height? Well, normally, logically, yes. But for a trapezoid, B1 and B2 are always the parallel sides, or else this formula will not work. So what's the height? That is the perpendicular side to those parallel lines. So this bottom part will be the height. And maybe you'd like to think of it as the trapezoid was standing up and it got tipped over. But at this point, it's properly labeled and you have everything you need. So go ahead and pause this and see, can you substitute your values into the formula and find the area of the trapezoid? You should have, oh, let's do it here. You should have got area is half. The height, remember, is a distance of 3. It's not 4. Don't just look at 4 and say 4. It's the distance from here to there. Very common mistake. Write it down in your notes to be aware of that and be careful. Okay, and this is all multiplied times B1 plus B2, which we labeled as B1 is here, while that height is right there, 0.1, and B2 goes up to 0.4, and we work it out. Half of 3 times 0.5, and that gives us 0.75. Once again, we can check just visually, does that trapezoid look like 75% of the entire large triangle? I'd say so. What's the area of the entire large triangle? And I'm talking about this entire thing. 1, right? All probabilities in a situation add up to 1 because there is 100% chance of something happening, right? Okay. Well, that's one way to find the area, but you're smart, you're curious, you're creative. See if you can find out a different way to find the area. Here's another way. I notice there's triangles. So basically, I first found the area of this large purple triangle right here. Using the same, actually using the area formula for a triangle, half base times height. Hopefully you remember that one. Then I notice this little yellow triangle, so I find that area, and then subtract the little yellow triangle area from the big purple triangle. I do that over there to get the same answer. So you have a choice, right? Do you like the trapezoid formula? Do you like the triangle formula? The choice is yours. So we've looked at these 3 area formulas. There's also a perimeter formula for the rectangle. Might come in handy. Remember, perimeter is the distance around. If you were to be standing here and take a lap around, how far would you walk? Now let's practice a little more before we wrap things up. A random number generator following a uniform distribution returns a real number between 0 and 4 with equal likelihood. What is the probability that x is less than or equal to 3? Test yourself. If you said B, that is absolutely correct. We're told it's uniform distribution, so we know all the bars are the same height. This is uniform distribution. equal likelihood, right? All the way from 0 to 4. And there are 4 bars divided up into 4 equal sections, meaning 3/4 of the bars are less than or equal to 3. So notice when you see that 0 to 1, that should tell you, okay, that's a range of values. That's one section, 1 to 2, and so on. And what we're saying is from probability that x is here, right? X-axis less than or equal to 3, that is all of this. This line right here is right on the edge. That's where it's equal to 3. So that's as far right as we can go. All right, what's the probability that x is not in section 3? 3 different ways to solve this. I have my recommendations of the faster ways and the slower ways. Let's see how you did. Answer is A. So probability x is not in section 3. Section 3 cuts off at this vertical line. So once again, we have a trapezoid. It looks different, but it's still a trapezoid. We have parallel lines on opposite sides here and there. So we label those sides B1 and B2. And now the height is actually from the ground up. So the method I used was my trapezoid formula, plugging in those values. Height, 0.2. B1 is distance from here to there. That's 3 to 5. So that'll be 2. And then B2, distance from there to there, 5. So multiply, add, multiply, and you get 0.7. That makes sense. 70% of this entire shape is below 5. Or at 5 or below. And finally, our exit ticket. This problem is a little more abstract, but I think you can do it. Give it a try. And the answer is A. Okay, if the probability that x is less than a is equal to 1/7, what is the value of a? Round to the nearest hundredths. It's takes a little brain power at first. What they're telling you is the shaded region right here, this dark shaded gray, is 1/7 of the total shape. That's what this means. And they're asking you what the x value is on the dashed line. To answer this, you take the total base, so from 1 to 4, and multiply it times 1/7. So that's a distance of 3. Multiply it times 1/7 to get 0.43. Okay, but you want to know where A is. It's not just 0.3, right? It's the distance from 0 to A. Have to be very careful with this problem. So we're adding 1 plus the additional 0.43. And that's it for today.